Imagine for a moment that elephants, those terrestrial giants we admire, were completely wiped off the Earth. It would be a devastating loss to the ecological and cultural diversity of our planet, wouldn't it? However, this tragedy has already unfolded in human history, but not with the elephants we know today, but rather with their prehistoric cousins, the majestic mammoths. Have you ever stopped to think why these giants disappeared? Or even how the world would be if they were still with us today? I'll show you everything you need to know about mammoths. First and foremost, it's important to clarify that mammoths were not a single biological species, but rather divided into several subspecies. When we hear the word mammoth, we usually think of hairy creatures with huge tusks, don't we? But did you know that these animals varied greatly in size and appearance depending on their habitat and stage of development? For example, the North American mammoth, standing at 5 meters tall and weighing 14 tons, contrasted with dwarf species, barely reaching 2 meters in height. While some species were similar in size to modern elephants, mammoths stood out for their larger bodies, shorter legs, and longer fur. Their tusks, larger and more curved, were a striking feature, although their ears were relatively small compared to those of elephants. In fact, mammoth ears were 5 to 6 times smaller than those of Asian elephants and 15 to 16 times smaller than those of African elephants, extending flat against the skull. The shape of mammoth ears even resembled the human ear more. Although the skeletal structure of ancient mammoths resembles that of modern Indian elephants, what really set them apart were their huge tusks, which could measure up to 4 meters in length and weigh 100 kilograms. In reality, mammoth tusks are one of the most fascinating research subjects and deserve to be explored in detail. They grow from the front of the skull and project upwards like cutting tools. Even mammoth calves had miniature versions of these tusks, which were a few inches long. These tusks began to emerge from the gums around 6 months of age and were replaced by larger tusks when the mammoth reached 1 year old. During the first 6 to 7 years of life, a young mammoth's tusks grew rapidly, much like the rest of its body. For instance, by the time males reached 10 years, their tusks could already measure between 3 and 5 feet, reaching up to 7 feet. In older males between 60 and 65 years old, tusks could reach from 11 to 13 feet. Scientists can learn a lot about an adult mammoth's life by observing the size and rings of its tusks. Similar to trees, mammoth tusks have rings that indicate the animal's age. Depending on the size of the tusks, researchers can also determine how many calves a female may have had. Interestingly, mammoth tusks typically curved upwards and to the sides, with the left tusk usually curving to the right and the right to the left. Mammoths primarily used their tusks for self-defense or for foraging, as confirmed by examinations of real tusk samples, where cracks, wear, and signs of use were found. Regarding the attachment of tusks to the skull, mammoths were very similar to modern elephants. Their nostrils were located above the forehead, approximately at eye level, and the skull structure resembled that of a whale. The brain was housed below the frontal sinuses, providing a broad area for secure tusk fixation. Over the years, scientists have made fascinating discoveries by finding mammoth tusks in various parts of the world. These tusks, which have spent a long time buried, have developed rings in a variety of shades, from hues of light brown to vibrant tones of emerald blue, purple, and even black. However, the question arises, do we truly understand the appearance of these majestic prehistoric creatures? Since childhood, we have been familiar with artistic representations of mammoths, but do these images accurately capture their essence? Determining the precise appearance of extinct animals is an inherently complex task. Typically, only fossilized bones are preserved over time, leaving significant gaps in our understanding. Although bones provide valuable clues about the size, proportions, and even the behavior of mammoths, information about details such as skin color, fur length, and external features like ears and noses is more challenging to obtain. However, mammoths, in their ancestral wisdom, left us some additional clues. Fragments of skin and mummified bodies have been discovered in locations such as permafrost, tar pits, and even caves, offering precious glimpses of their true appearance. It's undeniable that mammoths had impressive features. Their massive legs, sturdy like pillars, and round feet were adapted to face the challenges of their environment. The diameter of a mammoth's foot varied between 18 and 20 inches, with each foot equipped with 3 to 4 hooves, each measuring between 2.75 and 3.5 inches in length and 1.18 to 1.57 inches in height. Additionally, much like modern elephants, mammoths had feet covered with pads of connective tissue that expanded according to the weight of the animal, facilitating movement on wet and uneven terrain. And what about their fur? Scientists were blessed with the discovery of exceptionally well-preserved samples, providing an intimate view of mammoth fur. In many species, the fur was a mixture of light brown and yellowish-brown tones, forming a lush layer that extended to the ground like a majestic skirt. A striking feature was the fringe of coarse hair adorning the animal's head, extending to the eyes and shielding them from the wind and the elements. However, the most notable aspect of mammoth fur was its density and complexity. Comprising 3 distinct layers, the fur provided vital thermal insulation in cold and challenging environments. The outer layer, tougher in texture, offered protection against the elements, while the inner layers provided additional insulation. So, what kind of connection do modern elephants have with mammoths? Are elephants descendants of these giants or just distant relatives? Elephants are called primus in Latin, which is also the name of a species of mammoth. In fact, this word literally means first elephant. There are hypotheses that mammoths evolved into modern elephants due to factors such as adaptation to warm climates. Some people are certain that mammoths are the ancestors of modern elephants, but the truth is much more complex. The closest living relative of the mammoth is the Asian elephant. These two species share a common ancestor that lived at least 5.5 million years ago. This ancestor is a little-known and oldest species in the elephant family, called Primelephas gomphotherium. It is believed that this species was the first elephant to live in Africa. However, we cannot state with such certainty that mammoths were the ancestors of African elephants. From an evolutionary standpoint, the woolly mammoth was one of the most successful animal species of the Pleistocene, emerging in East Asia around 800,000 years ago. This species spread across a vast area, with remains found from Spain to Chukaka in Alaska and in the southern parts of Canada. The dispersal of these animals into northern habitats led to the preservation of their bodies in permafrost conditions, allowing scientists to learn a great deal about their physical characteristics and even their lifestyles. The longevity of mammoths, which averaged around 60 years, reveals many details about their lives. But how did these beings, with their relatively long lifespan, spend their time? Or how did they reproduce? We can start by discussing their diet. The primary foods of mammoths included herbaceous plants, tree bark, small shrubs, and mosses. Surprisingly, mammoths needed to consume about 550 pounds of plants per day to survive. This meant they spent roughly 18 hours a day foraging for food and constantly moving in search of new grazing areas. Their diet mainly consisted of coarse foods, which is evident in the structure of their teeth. Despite their immense size, mammoths had only a few molars used for grinding plants. Additionally, there was a very large tooth on each side of the upper and lower jaw. The mammoth's tooth had a unique structure, comprised of separate enamel plates, enabling them to handle even the toughest plants. The herbivorous nature of mammoths played a crucial role in their complex social life. Living in herds, they exemplified an evolutionary adaptation, aiding herbivores in protecting themselves from predators and collectively solving food challenges. Based on various fossil evidence, scientists concluded that these herds were typically led by an elderly female. The males, in turn, formed subgroups to assist in herd protection and often maintained a separate existence, albeit under the leadership of the primary female. Each of these subgroups was led by a dominant male. Additionally, there was a strong sense of kinship within the herd. Adult females, highly respected by other members, often cared for the offspring of other females. If small groups separated, they would forage individually before reuniting to form a larger herd, sharing the resources collected along the way. Unlike many other mammals, mammoth calves took a considerable amount of time to achieve full independence. Their sexual maturity was reached at 10 years old, after undergoing significant changes in their lives and behaviors, especially regarding reproduction. An international group of scientists recently studied the teeth of a male mammoth that lived approximately 35,000 years ago, discovering evidence of seasonal increases in testosterone levels. This finding echoes similar patterns found in the lives of modern elephants. Young male elephants, during their mating period, become notably dangerous due to the increase in testosterone levels. During this time, they emit low-frequency sounds audible over long distances, attracting some females while other males and some females tend to avoid them, given their more aggressive nature. This characteristic was also observed in mammoths, which may have influenced their interactions with other species in the region. A comparative study between testosterone levels in male mammoths and modern African elephants revealed significant increases throughout adulthood for both, with differences in the intensity of hormonal peaks. While mammoths exhibited a testosterone increase about 20 times greater during sudden peaks compared to elephants, researchers suggest that this disparity may be attributed to testosterone degradation in mammoth tusks over time. However, a test on a female mammoth showed no such increase. It is noted that male African elephants tend to stay with young herd members and reduce their aggressive behaviors. It is speculated that mammoths may have followed a similar pattern. As for mammoth extinction, scientists have yet to reach a consensus due to the complexity of the process. What led to the extinction of mammoths? There was no ice age or any global cataclysm that could fully explain the disappearance of a species during this period. The extinction of mammoths was inherently linked to a myriad of factors and occurred in various stages. At that time, humans had already developed their hunting skills and spread across vast expanses of the globe, exerting considerable pressure on other species. Simultaneously, significant climate changes occurred at a relatively rapid pace. Mammoths, adapted to their specific environment, did not have enough time to adjust to these changes. When these two crucial factors combined, it resulted in the population decline first, and eventually in total extinction. The reign of these giants over the Earth had come to an end long ago. So, if by chance circumstances had been different and these majestic creatures had survived to the present day, what would the natural world be like, and how would the interaction with humanity unfold? We leave this question for you to answer in the comments. Click on the video that appears on your screen to watch more content like this. Until next time,